Find all factors of a number using the rainbow method. There are a few ways of how to find all the factors of a number. However, I think the easiest and the most intuitive way is by using the so-called rainbow method. Once you get the basic methodology of this technique, more likely you always remember it. Plus, the visual aspects of the rainbow method is very effective to keep track of all possible factors of a number. How to find all factors of a number using the rainbow method? First, write down the first 9 elements of the bath of count numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Once you have the number on which you want to find all the factors, begin by dividing the number by 1, which is the first number on your list. Your first factor pair will then be 1 and the number itself. Don't be alarmed, as this is always the case. You will then write the first 2 factors with enough space between them. Next, move on to the next number on the list, which is 2. So that's if you can also get a factor pair. If you can, write the new factor pairs inside the first factor pair. Give it enough space in the middle as well. If you can't get a factor pair, move on to the next number on your list. You will repeat this process until you have found all the factors of the given number. The best way to learn this rainbow method and find all the factors of a given number is to go over a few examples. Example to find all factors of a number using the rainbow method. Example 1. Find all the factors of 18 using the rainbow method. We will start by listing the first 9 count numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now dividing 18 by the first number on the list, which is 1, we have 18 divided 1 equal 18. Therefore, your first factor pair is 1 and 18. We will write this first factor pair with enough space in between. This time, let's divide 18 by the second number on the list, which is 2. Does it give us a factor pair? The answer is yes, because 18 dividing 2 equals 9. So your next factor pair is 2 and 9. Let's write this factor pair on your rainbow diagram. Moving on to the next number on the list, we ask ourselves again, if 18 is divisible by 3. Sure it is. We have 18 divided by 3 equals 6. So after 3, we test the next number, which is 4. Is it 18 divisible by 4? The answer is no. Therefore, you cannot write the factor pair 4 as one of the factors. We are not done yet, because we have to go through all the numbers on the list until we hit a stopping point. Since we cannot make a factor pair 4, we move on to the 5 of 2018 is also not divisible by 5, so the next number to test is 6. But notice that you already have a factor pair of 6 in your rainbow. This is when we stop. We can now list all the possible factors of 18. 1, 2, 3, 6, 9, and 18. Example 2. Find all the factors of the number 42 using the rainbow method. A way to have a list of the count numbers will be at least from 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We should already know that any whole number is divisible by 1, which means your first factor pair will always be 1 and the given whole number. That is 1 and 42. Holding these two for a moment. Check it with the next count number in line. 42 is obviously divisible by 2. This is your factor pair, so find the rainbow diagram. The next count number to check is 3, since 42 divided by 3 equals 14. That means the next factor pair is 3 and 14. I'll leave it to you to check that 4 and 5 do not even divide in 42. This is your updating rainbow diagram of factors pairs. Moving on, we know that 6 times 7 equals 42, therefore you can include this factor pair in your diagram. After 6, the next number to check is 7. However, 7 is already one of the factors, as shown above, so we stop here. These are all the factors of the number 42. 1, 2, 3, 6, 7, 14, 21, and 42. Example 3. Find all the factors of the whole number 16 using the rainbow method. This one is actually very easy. Keep in mind the first 9 count numbers. Let's go through it together. We know that 1 even divides 16. How about 2 and 3? It's crystal clear that both 2 and 3 even divide 16. In addition, by doing a quick mental calculation, the next count numbers, which are 4, 5, and 6, can divide 16 without remainders. So for recap, the count numbers from 1 to 6 produce factors pairs. Again, I will leave it to you to verify that 16 not divisible by 7, 8, or 9. You might say that 10 divides 16, which is true, but 10 is already covered by the effect by 16. Below is the pre-Rainbow diagram of 16. The following is a list of all the effects of 16. 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60.